Hello everyone, welcome to Digital System Design. So today we are here again with a new video on our system design series, or I should say solution architect series. So in today's series we're going to be discussing about disaster recovery management strategy in our cloud management process. So no matter in which cloud we are, let's say we are in AWS, we are in Azure, we are in GCP or any other cloud, for example. So this topic is not confined to any of the cloud platforms. On the whole, it is a general, I would say, principle that we should follow in whichever cloud platform we are, or not, I would say cloud platform, but in whichever distributed environment our application is working. So distribution, or I would say disaster recovery management, it's very important aspect when you are working in a distributed application and you have a critical businesses to support. So let's say we'll be now you'll be wondering why I open draw.io every time, because I want to depict the actual scenario before you guys, just to explain you the entire stuff. So that's why we always go to the whiteboard just to explain the exact use case also. So let's say I am in India, or I would say I am in a specific part of an India, and I want to uh, set up a new website or web project. So for that web project, I am choosing any of the cloud platforms, for example, AWS, in our example as of now. So in this example, I have a UI application and I have a backend service for the same UI application. Now, considering my application has so much of load and I can't withstand my application if it goes down for, let's say, more than 8 minutes a year, or let's say little more than that. So I want availability to be a bit on higher side, very much higher side. In this case, I'm talking about a complete year. Now, if we predict in the air, let's say how are the disaster or natural calamities is gonna be around where my web application is running, or in whichever location my server is, will that location will be not prone to any disaster? No, we can't predict that as humans. So, considering that as one of very important architecture pillars, so we'll be discussing on that. So, let's say I'm in India. I have hosted a web application. So I have a web server here, I have a UI layer here, and I have a DB layer here, for example. So I have three tier architecture here. So I have UI, then I have backend, then I have DB. Now UI will interact with backend, and then backend will interact with the DB layer to get the data for you. Now, let's say our backend is lying into Mumbai region, okay? Or I would say Singapore region, for example, because I'm from India and if I'm hosting my website, so I would like to host it near to my users. So I would prefer in Singapore, for example. And similar way for my other servers also. So all the servers are in Singapore. Now, to make it more highly available, I have chosen multiple availability zones. So in Singapore region, I have deployed my application into multiple regions also. Considering to the cost factor, I want to deploy my application to different regions also. So let's say to make it very highly available, I have deployed it to two different regions. Or I would go to that example later on, but firstly let's confine to the one region itself. Let's say to make highly available, I have confined it to one region itself, and I have deployed it to multiple availability zones into that region. So let's say that is the initial use case I have. Although with this kind of configuration, I can't achieve very much high availability, which I'm expecting that it should not go down more than 8 minutes a year. So let's say we park that assumption as of now on the side, and we consider cost as the first factor, that we can't spend much on the infra as of now in the initial days. So that's why we have deployed our application on one AZ itself, or I would say one region itself in the multiple AZs. Now, let's say in the Singapore region, there is a natural calamity in some point of time in the year. So, but our servers are also there. So, in that case, we expect that, or we may be expecting that our servers may go down in that natural calamity situation. To withstand that, what can we do? So, there can be multiple strategies we need to implement such that our critical business services or critical business application should not go down. Now let's say I have only one backend service here. as it is a very basic application I'm considering. So I'm not considering big distributed applications like microservices. So I'm just having a basic backend application. So it has few API endpoints, and it is running on some API gateway and all that stuff. It's there. Now, the natural calamity is there. So there are two very important points which we need to consider going forward when we are managing the uh, our disaster recovery management. So those two points are, yeah, one is RPO and other one is RTO. So both these points we need to consider while we are planning for our disaster recovery management. So this is the first point that we need to take care of: RPO and RTO. Now, RPO is what? RPO is recovery point objective. Now, let's say in this case, our database is the data storage system where we are storing all the data. Now, in case and if any disaster recovery, so we need to understand. Let's say the disaster came at some point of time in the day. It was like 12 hours in the noon. The disaster came. So at that time, from that since that time, our application will be down until the servers are coming up. So we can assume that since 12 o'clock, our servers may go down along with the backend. Our database also may go down. So the data which is coming in, and probably if at 12 hours, if the DB goes down, so we may not have any data probably at next minute if the database goes down. So what can we do in that case? So we need to think of a backups actually on the database layer. So how we can take the backups, and those backups also has to be scheduled by some time, let's say 2 times in a day, 3 times in a day, based on our frequency or business critical applications. Now here comes the RPO. RPO is recovery point objective. Okay, which means that till which point you had the latest backup, and how much time or till which point of the database you can go back while you are managing, or while you are creating your server in another region to manage the disaster. So let's say we are talking about Singapore region. So I am actually creating my backend server now for managing the disaster recovery in Australia region, for example. Now, when the disaster came, I don't know, the database might have lost something, and 12 hours the data got lost because of the disaster. Now, for example, I had a RPO of 4 hours, which means every 4 hour my automated backup will be generating. So, let's say my backup was taken at 11 o'clock, and the disaster came at 12 o'clock. So, in that case, you may lose only 1 hour of your data. The assumption is maximum you can lose 4 hours of data, and minimum you can lose 1 minute of data. For example, if the disaster came on 12 o'clock and your database backup was scheduled on 11 hours and 59 minutes, so then in that case, ideally you lost data for 1 minute only. So you had almost backup for complete data at that time. Imagine the disaster came at 8 o'clock. Then you must have lost the 4 hours of complete your data layer. So that is the maximum time you can lose in that duration. So that is 4 hours. If you minimize it 1 hour, so then it may incur to 1 hour. So that entirely depends on the cost factor, how much cost you can bear for taking the backups. More you take the backups, or more RPO you have, let's say you have minimum RPO you have, so more cost it goes up. So that is one point. Then cost, then comes the RTO. RTO comes the recovery time objective. So it means how much time it will take you to create your servers, or set up your servers in Australia in case your disaster is coming in the Singapore region. So let's say your backend server is here in Singapore and you want to set up in Australia. So how much time it may take? So that depends entirely on configuration. Okay. So these are the 2 points we need to take care of while we are managing the disasters recovery at the first point. Now, there are multiple kind of strategies we need to follow while we are going for disaster recovery. One is the point backup, or I would say not point backup, it is pilot. Then we have warm up strategy. Then we have uh, warm up strategy, and what next? There was one more. Uh, Yeah, the multi-site active. So that is actually, I'll explain you every type of that. So then the last one is, I would say that should be the first one, that is backup and restore. Backup and restore. Okay. Okay. So there are four types of strategies you can follow. First is the backup. So now all these I have sorted based on the cost. The more you go down, the more heavy you cost have you incur. So when you say backup, it means you don't have any disaster recovery the way I initially thought of an idea and I made it on one region itself. You don't have anything in the second region. So I didn't manage anything for the second region from the start itself. Okay. So in that case, I'll be just taking the backups and restoring it on the next point. Okay. So then in that case, I don't have any another regions VPC. I don't have any servers in another region whom I can shift the traffic to immediately. I don't have. I just have backups and I can restore those backups. So that is the basic level of disaster recovery management, and this is uh, least cost effective among all these. Then you have pilot. Pilot, it means you have your data layer, or I would say your database is available multi-region, so that if one region goes down, the same database will be active in another region also. But at the same time, you may have to pilot your server in that region at that time, so that time may go in terms of setting up that. So that is pilot. Then we go for warm up. Warm up means we have the another VPC ready in the another region. We have one server also ready for our service. Okay. And then we have DB also ready. But the only difference here is we have everything ready, but we are not scaling that. We will scale that only when the traffic will be high and we'll be auto scaling that based on our configuration. So that is warming up. Warming up means you will give one server to the user, or I would say to the site, and as the users get transferred to your new region, so your elastic load balancer or your any of the configurations, they will auto scale your configuration and add more servers when the traffic increases into the new region. Now, this is a bit of cost heavy as compared to the pilot and backup, because you are additionally creating one server and all that is always active and all that stuff. Always, not I would say always active, but it would, I would say, just DNS switch we need to make to that. I would say setup, and then it will be automatically working in that region. So that is warm up. Then next comes the multi-site active, which means as the initial configuration I was talking to you in the initial time of this video. So you will initially deploy your application into one region, and at the same time you will replicate that complete web servers in another region also. So you will have load balancers in one region, and you will have load balancers into another region, and your traffic will be shifting to these two regions based on the user load. Sorry. So in that case, if one region goes down, so the complete another region can take your complete traffic. So in that case, so your shifting in that case will be very easy, and there will be no downtime in that case. So you can say that these methods are sorted based on the cost, from least to highest cost, and then you can say downtime. In terms of downtime, it is sorted from the highest downtime to the lowest downtime, because in multi-site active you will have lowest downtime, in pilot, in backup you will have highest downtime. So that way these processes are defined. Now, it depends on entirely on your requirement, which you have to fit in. Multi-site active, it's very, I would say, less laborious, and I would say very much efficient if you want very high availability all the time in the year. So then multi-site active is the one which you should go for, but that goes for the extra cost also, which you may have to bear in case if you are going for multi-site active. But if you are mission critical application, then that is the only option for you. Warm up is also another option, but in that case it may not scale up immediately if your application is very critical. So yeah, that's what I want to explain you in today's video. So it is completely on the disaster recovery, and it is not relevant to any of the platforms, any of the cloud platforms. It's not tied to that. It's actually architecture principle, architecture pillar, which we should follow. Thank you everyone for your time. Have a nice day ahead. Thank you. And do subscribe our channel and do like and share our video. Thank you.